Hello, everyone. Welcome to BiogasWorld's safety webinar discussing the security and safety of biogas and RNG projects. As a reminder, this webinar is being recorded and will be shared with participants following the webinar. In addition, if you have any questions for our presenters, we invite you to write them in the Q&A tab, and we will ask our presenters following their presentations or in the Q&A at the end of the webinar. BiogasWorld hosts new webinars each month to discuss the opportunities and challenges within various country markets. Be sure also to join us on our biogas community website for the latest updates and to network with companies in the biogas and RNG industry. I would like to thank our presenters for joining us today. Dave Ellis, CEO and Principal Engineer at Azura Associates, Katrin Kayser, Environmental and Process Engineer at IBBK Biogas, and John Bickers, Vice President of Business Development at MRU Instruments. Our first presenter today is Dave Ellis. Dave from Azura Associates has more than 30 years of experience with complex and unconventional industrial wastewater and anaerobic digestion challenges worldwide. While many digesters are fed with established feedstocks like sewage, sludge, and manure, the team finds it more fun to explore the wider range of organic waste that can be diverted to them. So with that, Dave, I will pass the floor over to you.
Excellent. Thank you, Ryan. Appreciate that. I will cross my fingers, share my screen. Let me know if it's coming through okay on your side.
Yes.
It's good. Excellent. Okay. Thanks so much, Ryan. So the purpose of the presentation here today that I'm giving is to give a wide overview of the types of safety risks you can expect at a biogas facility. So from receiving to offtake, whether it's gas and digestate. Some of the things we're going to discuss here will be the safety risks that comes from the process itself and the nature of the materials that we're working with. So this will be less about specific safety pieces like equipment, mechanical hazards. Certainly the equipment suppliers will be best to speak to those. And John's going to talk about some of the gas hazards as well with these systems. At Azura, we're bioprocess engineers. So primarily, we speak on process-related safety items. There we go. So most of you are familiar with the main process steps in anaerobic digestion. On the left-hand side, we have different flavors of organic feedstock materials that go into the digester tank, some sort of container of some kind to keep the right environment. In there, that material biodegrades to produce biogas. The undigested material called digestate is discharged out the end of that facility. The biogas is produced from the biodegradation process. So both the biogas and digestate can be used as is, or they can be purified to more up-value uses like biomethane, which can also be called renewable natural gas or RNG. And the key to this whole operation is the biological process that goes on inside the tank itself. Now, since we're dealing with biology, the environment inside the digester tank can look stable from the outside, but it's always changing. So even if it looks like nothing has changed and you're operating as usual, the bugs are always working, even when you can't see it. So think about watching grass grow in the summertime. Today looks very much like it did yesterday, usually. It doesn't look active, but deep down where you can't see it at the microscopic level, there's a lot going on. So for a digester operation, you might see a sudden increase in hydrogen sulfide gas in the biogas one day, and it may not be immediately obvious where that comes from or what to do about it. So specifically here, I'm talking about hydrogen sulfide, or H2S. So that's a gas. It's a component of most biogas streams. It's extremely hazardous and can certainly kill a person in small amounts over a short time period. So it is one of the hazards. Luckily, the biogas is supposed to stay in the tank or in the pipes, in the engine, in the upgrader. It's not supposed to be out where someone can encounter it. The H2S comes from reactions that break down the proteins or even some of the different process additives that might be part of the feedstocks. So here are some examples of feedstocks that can increase your H2S risk. So first, high protein feedstocks like spoiled meat, for instance. Proteins contain a lot of sulfur. So when that protein biodegrades, a lot of that sulfur is released, and that can give rise to hydrogen sulfide in the biogas. So say, for example, a refrigerator breaks down at a grocery store. Now you might have 3, 4, or 5 tons of spoiled meat to dispose of. Another feedstock could be from processes that use aluminum sulfate. Aluminum sulfate is used a lot in wastewater treatment. So for DAF sludge. So DAF sludge is a dissolved air flotation process that collects the greasy skimmings off of the top of, say, an industrial wastewater treatment plant. Luckily, though, there are plenty of ways to manage hydrogen sulfide, like different iron additives that can be added to the digester using a sulfur oxidizing bacteria in the digester itself, or external to the digester. There are different equipments that can be used to help with that. But one of the keys here is you can strategically manage your feedstocks to minimize your hydrogen sulfide risk. Let's see how this could work, right? If you've got a load of spoiled meat of a high protein feedstock, that can increase your H2S risk. If we have a different feedstock that's high in iron, like this DAF sludge that is produced using an iron chloride in the wastewater treatment process, these two react in the digester in a way that one counteracts the hydrogen sulfide risk of the other. Now, hold on a second, though. I said something strange. Both DAF sludges, just different things happening in how they are made. So the sludges can be risky or a useful tool, depending on how it was made. Let's see here. So the photograph on the left-hand side. So this is a DAF sludge from a very large dairy milk facility in Mexico. I was at last summer. So they use aluminum sulfate in their wastewater treatment process. The DAF on the right-hand side, that's you skimming that greasy material, that's scraping grease from one of the largest chicken wing manufacturing plants here in Canada. That facility uses an iron chloride as part of their wastewater treatment. So this is to say that it's important to understand where your feedstock comes from and how they are made, and how that may impact your process and create some challenges. Also, to be aware of the safety and process risk comes from mixing the feedstocks. So if, for example, you have a receiving pit that's filled with an acidic feedstock, like fatty wastes, and the next day you receive some alkaline material, like bread waste that has some cleaning products in it. Well, these chemicals can react in the feed tank itself and cause foaming that overflows your receiving pit. So this is a demonstration I did in my garage lab several years ago, mixing the different materials, letting it react for about 2 hours, and it foamed up pretty quickly. So foam can pose a number of risks. In the feed tank, the foam is slippery, so if it's out on the ground, it is definitely a slip, trip, and fall hazard. Also here in Canada in wintertime, we can have ice issues as well. It can increase the risks of slips. It exposes operators to potentially biohazardous material. So like rotten meat, for instance, can contain salmonella or other bacteria. And there's definitely an opportunity for an odor risk that increases the chances of odor complaints from your neighbors, and of course, regulatory scrutiny and intervention for sure. So far we've mentioned a few of the process risks related to feedstock. So in the time we've got today, I'm going to follow one real-life example of some of the lesser-known safety risks within each of these different process stages. So we've mentioned different flavors of feedstock. And one way to manage that is in your design of multiple feedstock receiving tanks or pits to hold the different types of material. They can be solid receiving pits, liquid receiving pits, sludge or slurry receiving tanks. This design gives the operators the tools they need to then be able to manage and blend the different feed materials to get consistently great gas production. So we can have some high solids materials, and we have some very high calorie fatty wastes, for instance. And how the operator manages that is a day-to-day real-time process control factor that the operators work with. If you have fatty materials coming in 3 days per week, being able to blend in that fat over a 7-day feeding cycle helps to stabilize your gas production. And moving on, so looking at an example from the next process steps, looking at digester operations, right? So when foam occurs in the feed tanks, that's one issue. There's a different thing that happens if we have a biological foam or foaming in the digester itself. So foam, first off, can fill up the tank to its high level and actually cause just a physical overflow and an environmental release. Foam can also be hazardous because it can plug or compromise your pressure relief systems, your safety systems. Flame arrestor plugging is definitely something we've seen. Even if the foam doesn't actually reach up and get into the gas train, the presence of a foam layer tends to produce a lot more aerosolized materials that can get into the gas train. And so the images we see here, so in the top right, this is a underground feed tank pit photograph I took a few years back. So that had a foam event where it had foamed up and run down the side of the hill. The picture in the center at the bottom, so that's the picture of a flame arrestor that's been removed from a process train, from biogas safety train. The aluminum plates, they're normally new and shiny and very clean, as the one in the center shows. On the left-hand side, though, we see that after some about 14 months of operation, when I took this picture, the plates had quite a lot of physical material on them. So there was scale, there was tar and wax builds up, there was quite a bit of chemistry going on fouling that system. You'll also see there's corrosion and pitting. So there is the opportunity for foam to compromise the physical safety systems. Talking about biogas handling, one of the issues that we can see is siloxanes. So siloxanes is a material that's present in personal care products, so deodorants, soaps, shampoos, those kinds of things. When siloxanes are heated up, as in an engine, for instance, that is taking biogas and making electricity, that can cause the formation of glass-like line coatings inside the engine, on the pistons, on the rings, and ultimately, cause a tremendous amount of damage to the engine. Municipal waste, like the organic fraction of municipal solid waste, OFMSW, or source separated organics, so curbside organics, are all things that have the risks of siloxane presence. And so these are issues where knowing your feedstocks and knowing what's in them can help you manage your system to make sure that you don't run into siloxane issues. Additionally, upgrading. So a lot of folks understand that your biogas is mostly methane and carbon dioxide, and we're measuring that in percent levels. So 55% methane, 60, 70% methane, 75% even, we've seen once or twice. But what else is in your biogas? And that's at the parts per million level typically. We know that there's hydrogen sulfide from the sulfur. We know that proteins have a lot of nitrogen in them, which can become ammonia. We also see things like VOCs and terpenes. Now, these can be treated in some upgraders, and some upgraders, these can be actually damaging. So understanding the trace components is an important factor, again, to make sure that we're able to manage those things appropriately. Again, if they're not present, that's terrific. If they are present, it's not a showstopper, it's just something that needs to be engineered into the controls and the operation of the system. And then let's talk about digestate storage here in trucking. So digestate holding tanks. So when digestate is stored for a long time, it will can accumulate small biogas bubbles in it. The H2S can accumulate under the surface. And this residual biogas can then accumulate, especially if there's a crusting layer forming on the end storage tank. So unfortunately and tragically, every few years on farms, often someone is very seriously injured or even killed when mixing a manure holding tank. We haven't seen this in digestate systems that I'm aware yet, but certainly it is absolutely possible. We have seen digestate systems with crust on them and with potential gas buildup. So this is something that we haven't seen a lot of, but we know from the manure industry that this is definitely an issue and something to be mindful of. So when the tank is mixed, the crust is broken up, the small gas bubbles coalesce into large bubbles, which can come off of the tank rather quickly, and in some cases actually injures or overwhelms the operator who's mixing that tank. All right, and so the overall purpose, of course, of this is to raise the sensitivity to the issues, give you a taste of what some of the possible things are to guide your thinking going forward with your projects. Of course, this is just the tip of the iceberg. We have some more material on our YouTube channel if you want to watch more about feedstocks and anaerobic digestion. Ryan, well, back to you, sir.
Thanks, Dave, and thanks for your presentation. Maybe one question before we move on. So,
Yeah.
How can I safely test if mixing feedstocks will be a problem?
Excellent question. So, and the first and easiest method is if you take a simple 20-liter pail, you actually half fill it with the material that's already in your receiving tank, and then you add in the same amount, so a 1-to-1 ratio of whatever your proposed feedstock is. Now, you don't need to go to a lab, you don't need to do exhaustive chemistry, but just physically mixing the two in a 5-gallon pail and watching it over the next 2 to 4 hours, that's going to tell you a lot, as if you would expect any rapid gas production or anything, I'll say interesting to happen, much like in the measuring cup test that I had in this previous slide.
Great, thank you.
Well, thank you.
Thanks again for your presentation. Next, we have Katrin Kayser. Katrin is an environmental engineer who has been working in biogas since 2005, including 5 years in a German engineering company for AD plants. Nevertheless, Katrin is a biogas generalist with a broad overview of biogas-related topics, currently working as a consultant, trainer, and project manager with IBBK Fachgroup Biogas, or simply IBBK from Germany. Katrin, I'll pass the floor to you.
Yeah, thank you very much, Ryan. Today I will give you a short overview of risk assessment on anaerobic digestion plants, and thanks, Dave, for preparing this with your presentation. Just maybe briefly about IBBK. We are from Germany. We are consultants and trainers on the in biogas. We provide technical support, due diligences, just to give you an idea about the range of services that we offer. And within our trainings in Germany, we have a strong focus also on safety related trainings. And here we often find that operators are a bit hazardous on how to do a proper risk assessment. So I would try to give you an idea on how to simply approach this topic. So when we look at anaerobic digestion, there are usually, and safety on biogas plants, there are usually 3 questions that do make sense to consider. So what might happen? What can be done about it? And third, who is responsible? The third question is, at least in Germany, fairly easy to answer. It's the owner or operator who's responsible for health and safety on the biogas plant, at least with regards to operation. So we will no further discuss this, but look more onto the first 2 questions. So what might happen? I think everyone who's involved in biogas or anaerobic digestion has some ideas. And even if I talk to people who are not, most of them think about explosion. So when you ask them what's the hazard on a biogas plant, one of the first replies is, oh, it'll be explosion. But we have many more hazards. It's asphyxiation or toxic gases, high voltage. We have biological hazards, as Dave has mentioned. We have also, Dave has shown a nice picture on this, hazards on the environment when there's a spilling from the tank. You can fall down, you can stumble, you have machines that start automatically, they're hot surfaces, you can squeeze your hands, and in the CHP room you have noise. But that's only maybe the most general things that are hazards that exist on a biogas plant. And then you can ask yourself, so what can I do about this? So, and a structural approach would be to do a risk assessment and implement safety procedures. And this has two aspects to it. One is during the planning and the design and the construction of the biogas plant. This is what the manufacturer, the planning engineer has to consider. He select a proper components, make sound construction, and then hand over a documentation also that includes how to operate the different part of the biogas plant. But on the other hand, there is the day-to-day operation where the owner and operator has to think about safety and has to do the risk assessment for day-to-day operation. And this needs to be done to prevent hazards, or if you cannot prevent, find ideas on how can you reduce the remaining hazards as much as possible. Are there any technical measures to protect persons? Is it possible to keep people out of hazardous areas? One very important part is capacity building and training of the personnel, because when people are trained, they perform better under stress level. They know what to do, and then the likeliness of having a little bit of control over the event is higher. And also it's important to use personal protective equipment. Okay, so identification of hazards. The first question, is there a hazard? I skipped the no, because on a biogas plant there usually is a hazard. When you say yes, then you need to think about appropriate safety measures and precautions and how to implement them. And then you need to monitor and evaluate the measures you have chosen are suitable and effective. If they are, it's good. Then you record what you do, and this is part of the documentation that you need to have on a biogas plant. If you find even after some time it's not so suitable or not so effective, you have to start again at the point where you find that it's not working as you had intended it to work. When I started looking into this topic of safety on biogas plants, I found a nice paper from Nellie J. Brown conducting a safety walkthrough on a farm from 2007, which you can actually download. And I would like to share this with you because it's very hands-on easy to understand and good for anybody who has starts to look into this. So how she starts is that to sketch your own process layout or process flow diagram. That can be in simple boxes. It's just important that you have all the steps that are that you have on your biogas plant, that all equipment is included, or all main blocks. Like here you see the manure collection and other feedstock, the anaerobic digester, the digestate separation, biogas distribution system. For your plant, it can look completely different. It's just important that you note this down, or that you maybe take the site layout and work along that. Then you look at each step and think about, how is this task done? And how could people get hurt, or how could things go wrong when they do this task? And it's not only important to consider the operator's point of view, so the day-to-day normal operation, but also to look at what changes when you do maintenance, when you have to empty a digester, or if you repair the engine, what changes and how can you involve, what needs to be done then. Also look at history, the history of work-related incidents. Maybe you have also heard or seen something in the news that hasn't happened in your plant. Think about this, include this. And also think about, how can an accident or an incident in this part of your biogas plant affect the nearby buildings or the total plant. And I brought you a very simple example when we just look at the anaerobic digester. What an operator should do every day is go up to the view glass and check the liquid level. And the view glass usually is somewhere on a level where you have to climb up. In this case, on the photo, you see a nice staircase with the handrails, so that's the safe way to get up. But sometimes, I'm not sure about Canada, but in the German agricultural sector, you'd sometimes find a ladder to go up to the view glass, and there you have a falling hazard. So that's not safe, at least not if you have to go there every day during sun, rain, storm, freezing weather. When you look into the view glass, are you sure that it's gas tight? Or maybe you're not sure, then you should use an X-certified lamp and a gas detector, because there could be an explosion risk. And when we think about maintenance and repairs, after 8 to 10 years, maybe you need to change the double membrane gas holder roof. What is important is that you find a company who is experienced with this and has maybe a certified company. We have a strong discussion about this in Germany, because I think this year alone we had at least 3 incidents where someone fell into the digester during this work. So and then the operator and the company, they have to agree on how to do it safely. So each party brings their own risk assessment, and you cannot just say, okay, you guys are the experienced ones, you do it and done. They also have to provide a risk assessment, how they ensure their workers' health and safety on your plant. To give you an example, one of the first steps that need to be done is to open the bolts that fix the gas holder roof to the digester brim. Also, you have to climb up. And when you open the bolts, then gas will start to release, and you will have a toxic gas and also an explosive atmosphere. So how do people work there? Do they work on a scaffolding? Is it a fixed scaffolding that goes around the tank? Or is it just a movable scaffolding? Do they wear gas detectors? Do they use X certified tools? Do they need breathing apparatus? That is those are things to consider with regards to changing the membrane gas holder roof. Only at the first step, then there comes the next steps, but also need to be considered. So what this publication from Nellie J. Brown does nicely, she provides for each step some guiding questions and also some examples of preventive measures, which is really nice if you have an idea, but are not sure whether you have covered all the topics that are relevant. And with this, I hope I could give you a general overview on how to approach safety or risk assessment on a biogas plant. If you would like to know more, we have our next online training in February. So it would be nice to meet you there again. Just click on our website and check it out. And until then, stay safe. Thank you very much.
Thank you for your presentation, Katrin. Maybe one question before we move on. So you have shown some of the warning signs. So from your experience, do you think that operators understand what the signs mean? And if they don't, is there like text to go with it?
That's an interesting question. When we do the safety training on here in Germany, something like X-proof, the explosion or the toxic is quite well known, obviously, because that's the immediate. The thing about environmental hazards or maybe asphyxiation is often not so clear. But you can find all the information when you just Google warning signs biogas. You can Google this, and during our trainings we also talk about this. So there's places to learn this. Thank you.
Thanks, Katrin. Thank you again for your presentation. Next, we have John Bickers. John has spent his long career in the measuring and control industry with an emphasis on process instrumentation solutions. At MRU, he brings his market experience to support the growth of sales and marketing pursuits. John, I'll pass the floor over to you now.
Great, thank you. I'm glad to be a part of this. So appreciate our other speakers who've given a good overview on how to approach operations of these plants, whether it be digesters or even to move on to processing plants and engine applications. So I'm going to drill down more on sort of the hardware and tools that you would utilize to implement and keep your people safe. Next. So clearly we're dealing with a lot of, so the composition of biogas, pretty much everything about it can hurt you. So we know that methane is very flammable and explosive. It only takes a small amount, especially in the presence of air, that we can have a fire or explosion. CO2, although it's an inert and not flammable, because of the high concentrations that we can see in biogas, if we were to breathe this in directly, it can be lethal, especially if it's displacing oxygen. And so, you know, we have CO2 in the atmosphere. Even in the city, you might see 1,000 parts per million. That's rather normal. So that's around 1%. But as we get into the higher percent levels, say greater than 8%, this can be dangerous to your operators. Oxygen is a component and obviously key to allowing that combustion. And as Dave touched on, hydrogen sulfide is very present in all of these biogas applications. And although it's primarily poisonous, which is probably the main thing to be concerned about, but also, as he touched on, similar to the siloxanes, it's highly corrosive, especially as you are going to put this through maybe a cogen application also can be bad. Also, and also even when you maybe just do a combustion process, this also will then become SO2, which is a greenhouse gas that we do want to be cautious of as far as what we're releasing into the atmosphere. There are these other things which are, again, can be harmful to you. The hydrogen, obviously, even more explosive than the methane. Carbon monoxide at high levels is very dangerous. Ammonia and moisture. And the moisture, of course, then makes the hydrogen sulfide very acidic and creates a lot of problems. Next slide. And just to strike that point here we can see actually just how deadly and how dangerous H2S is. And so, just a few hundred ppm, again, with long exposure can be very, create a bad health situation. And then to get to 1,000 to 2,000 can be just cause instant death. The good news is that generally most digesters are not going to that high level, but very often you can have landfills that go very much above that. The good thing about being in most of these applications is that you're in an open air environment, and so it's going to dilute quickly, but still you need to be very aware of it because it is very dangerous. Next. So from a hardware side, these are the main devices, especially for gas analytics and looking at the gas to keep people safe. So as Katrin mentioned, you really should be having your people, especially if they're outfitted with personal safety monitors. It's probably, of all the things that we're going to cover today, probably the most important, the most critical as far as keeping people safe. As far as portable and handheld meters, these are really for process evaluation. But again, they do relate to safety in the fact that we want to make sure that these processes are within the limits of what they should be, such that we don't have too much H2S production or we don't H2S production and other things where we're getting in front of, and we're going to be proactive to understand that we have perhaps created a situation that's unsafe. And so these devices really give us our great troubleshooting tools, as well as evaluating the health of your process. Stationary, this allows us to have 24/7, and this is really for monitoring, control, and reporting, so that we can have the systems working properly and optimized for biogas production. Stationary detection, these, although they can help you in assisting for a safer environment, probably the main thing to understand is that their role is really about environmental. And so depending on where you are, especially at landfills or at some RNG upgrading plants, that there are environmental concerns that you need to be addressed. And these are generally what you would do with stationary detection systems. And then portable leak detectors, Katrin mentioned these as well. And so these are a good way to, again, to just identify where are the problems, where are the leaks, so that you can understand where to address and fix, potential hazardous areas. Next slide. So when it comes to personal safety monitors, you'll generally find that there's single gas, which are dedicated to, just one composition. In the situation of biogas and RNG, it'd be highly recommended that you do a 4-gas, and specifically of the main gases that we're interested here. So LEL, that's going to be sort of a combination of all of those explosive gases to understand what's the potential for those igniting and causing an explosion. Obviously, from an oxygen standpoint, we want to make sure that there's adequate oxygen so that we don't, again, have suffocation issues and people having a lack of oxygen. And then we spoke about H2S and CO as being poisonous gases that we also want to be able to have. They can be a fair cost, but again, if you consider what the liability that you're subjecting yourself to, it's really a small price to pay. The other thing I would say is that in many of these applications that you've got operators working on their own, such that there's no one around to assist them should they get into danger, and these devices can help prevent them to get into a dangerous situation. Next slide. So then we have the portables and handhelds. And again, these are primarily for process. They're going to be measurements made sort of in the pipe or vessel. Generally, they're going to measure our four main gases of methane, CO2, oxygen, and H2S. But they can also do other things, which gives you some other diagnostic information so that you can know temperature, pressure, flow, and even some may have an auxiliary device to do leak detection so that you get a multifunction type of device. These can be used for just spot checking around a digester, but they can also have software and firmware that's well suited to doing wellhead testing so that you can optimize the biogas coming from a landfill. One of the things that you should be aware of, especially when you have these portable and handheld meters, is generally, so there's a pump inside of these, and it's bringing the gas through past the sensor so that you can make the measurement. But that's generally going to vent outside right there at the instrument. And so again, if we have high concentrations of some of these poisonous gases, your operator could be subjected to those. So just want to make sure that they're operating generally in a well-ventilated area. So be very concerned about confined space. And if there are some options where you can do an active pump that will move that gas away from, the operator's face, but just be aware that as you get into these high concentrations of gases, you could be subjecting operators to it. Next slide. So, and then for stationary, again, this is really about process control. So there are inline meters, and those are generally dedicated single gas devices. They're going to be mounted in the line and can be more cost effective and at least still give you a good sense of where you need to be. But more and more people are going to extractive analyzers. These have the capability of doing, all four gases or even additional gases. And plus, we can also bring multiple sample lines. So let's say there's an H2S conditioning system that is pre and post. So you've got raw gas, and then we're going to condition that gas before it goes to a cogen. So we'd have a two gas line input for those. Because we're working with natural gas, and as Katrin mentioned, things need to be EX here at least in North America. It's going to be UL or CSA Class 1 Div 2. That's what you're looking for as far as certification. For these outdoor applications such as digesters or upgrading plants, please be aware that if it's not a confined space, so if it's outdoors, just moving 15 feet away, though, does move you from a classified to a non-hazardous area, which can generally be give you another level of safety, and also there could be cost savings as well. Next slide. So I mentioned about the stationary detection, and so these are, again, they're really meant for environmental concerns. They can support your safety plan as far as, fair warning, especially if people aren't around, and also that would be able to look at those systems to know what's the condition of that environment before going into it. But again, these should not be relied on as far as for personal safety. Next slide. And then portable leak detectors. So these are very cost-effective ways to locate and troubleshoot for leaks whether they be in piping processes or at the rim of the digester. So often these are going to be dedicated gas devices. There are some multi-gas, but anyway, these are meant to help you locate where you could have potential leaks. There are really just two types of these. There's a passive, which generally means it's going to be sort of within the area, but you can also, they can be done with a pump such that that you get a faster action. It's pulling the sample through the meter. It gives you a much faster response on these detections. Next. So this is a very big space for us, and we have a number of solutions. And so we do offer the gas leak detectors, both the passive and with built-in pump for fast. We do have our Optimax handheld meter, highly functional, again, 4 gases plus pressure, flow. Actually, this product is unique. So if there are applications where you are generating electricity from cogen engines, these can also be utilized as a multifunction device to even do some of the emissions testing on those products. Then we also have a larger portable, and this allows you to do 2 days of data logging. So if you want to do some process evaluation to see how things are how your production is going, how different feedstocks are impacting the gas output, and you want to see that over time, this allows you to do that. Not quite in the biogas space, but still similar. We're seeing obviously an uptick in what's in hydrogen production as far as utilizing when we go to the RNG works. And then the stationaries, of which we can do both biogas, RNG, and we also do have a syngas analyzer for that as well. Next slide. So we're also a German manufacturer, and we've been doing this for now over 40 years. We have a great competence in the sensors that we utilize for these tools, which are primarily NDIR and electrochemical. And so we have a high level of competence in utilizing those sensors in these applications. And we do have a global footprint with partners around the world. As far as North America, we do service our customers out of our Houston location, and we are able to provide quick deliveries. Plus, we can do full service calibration and even in-field startup. So we're a very good vendor in that respect. So next slide. So thank you guys very much for your time. And if there's any questions on how our measuring solutions could help you with your safety plans, please reach out to me and be glad to help.
Thanks for your presentation, John. Maybe before we move into the general Q&A, so is there any correlation between safety and process biogas measurements that might be helpful for operators?
Yeah, so I kind of touched on this before, but yes, by understanding that the process is operating within those parameters that it's designed for, generally will help to prevent a lot of safety issues. It's kind of, as I think, which Dave touched on, where you can have runaway situations or things out of control. This is generally where you're going to create your bigger safety concerns. You know, when things are working right and the gaskets are tight and everything's the way it should be, and you know that from an operational standpoint, then generally it's going to will feed into a proper safe operation.
Great, thanks. And what's the typical distance for the leak detectors?
So the leak detectors, they need to be close by, and so generally you're going to be within a feet to inches as far as locating those. Generally, they're kind of like a Geiger counter with a greater signal. So as you're pinpointing, you'll get a greater signal response.
Great, thank you. Maybe one for everybody. So in North America and in Northern Europe as well, there's a hot and cold weather. How might these factors change when you apply it to a year-round warm climate? So Dave, I'll send that over to you first.
Oh, sure. Thanks, Ryan. So let me think about this. So in all the organic material that is collected, whether that's manure, whether it's curbside organics, it starts to degrade more and faster in the collection stages. So on the curb, when it sits in tanks, in collection trucks, all that material makes organic acids. So the feed becomes more acidic, becomes more odorous faster in warm climate as compared to cold climate. So I guess I would say that's when it's probably even more crucial to pay attention to your receiving area, your odor control, your feedstock sources and suppliers, if you're in a warm climate or a year-round warm climate for sure.
Thank you. And Katrin, you want to jump in on that?
Yeah, I was thinking of what does it mean warm climate, and what does it mean with regards to plant technology that is used, and the size, whether it's comparable, if it's comparable technology to what is implemented in Europe or also in Northern America, then I think in addition to what David mentioned, the need for risk assessment, operator sensibility does not change, is the same. When we look at smaller systems like household style biogas plants that are often also installed in warmer climates, or simple lagoon digesters, the risk is, I mean, it's always an explosive gas, and that you always have to consider, and also H2S, but the volume is a bit lower, or considerably lower in household systems, and the dilution is a bit higher. So that is where we need to look at when discuss when we look at warmer climates. That's from my perspective.
Thanks. And John, is there a difference in the analyzer efficiency or effectivity?
No, generally in warmer climates, no. It's really when we get into colder climates that we need to be concerned. So most of the sensors, they are temperature compensated, but as we get close to and below freezing, we need to take care about how we're going to address to keep those sensors warm, because we're dealing with moisture. We can have freezing applications, but also just the outputs of those sensors change once we get into colder temperatures.
Great, thank you. And just as we approach the end of the hour here, maybe we can get a few concluding thoughts from each of you about plant safety. So maybe reverse order. John, do you want to start that?
Well, obviously, it's a critical thing that without safety, you're not going to be able to stay in business, and so you need the proper planning, but then also as far as the execution, make sure you have the proper tools for that execution.
Thank you, Katrin.
When we started training, offering training courses, safety was only the side thing. That was something where no one really wanted to listen to. It was many more interesting topics. But nowadays, with the large-scale biogas plants and the professionalization of the anaerobic digestion, safety becomes, or became, at least in, I can say for Germany, very important, and people are being much more aware of this, and still we have dramatic accidents. So there's still room for improvement, and I really encourage everybody who owns and operates a biogas plant to look into this, and to stay safe in day-to-day operation.
Thank you, Dave.
All right, thanks, Ryan. So I would echo, I think, what Katrina said. We know that unfortunately a lot of farmers do not come from a safety culture, whereas the professionalization, the the lessons learned, the hard lessons learned from, say, the oil and gas sector coming into the renewable natural gas business, I think has really increased the overall level of awareness, the use of, say, HAZOP reviews and these types of systematized safety processes. I think this is a tremendous boost to the industry. We're still seeing, sorry, I had to edit that for a bit. We've been involved in a number of confidential, major legal matters around digesters where things have not always gone right. And typically what we see is, because it's a biological system, because it's changing all the time, it's a waste stream. So there's a requirement for some additional sensitivity around that there might not be in, say, the oil and gas sector or the manure sector, where it tends to be more stable feed material day after day. So going through the risk assessment, the risk analysis, as Katrin was saying, that's terrific. And with a lens to what changes when it's a holiday period and we have a different type of food waste coming. If you're a food waste digester, what's different in the summer when it's plus 30 degrees outside, or what's different when it's minus 10 degrees Celsius and freezing conditions? Is the facility weather hardened appropriately? Are the gas meters going to have a liquid condensation? How does that be engineered in to not be an issue? So it's the changes from day to day and season to season that we're still seeing people missing in their sensitivity. So absolutely, everyone have a really safe day. Appreciate you being here and just really being careful and having your eyes open to how things can change potentially when you're not looking. Thank you.
Thanks, Dave. And that concludes our time today. As a reminder, the webinar recording will be shared with participants next week. If we were unable to get to your questions, we'll share them with our presenters and invite them to send a response to the question via the biogas community. We invite everyone to join us on our biogas community platform to stay up to date and view content from our Biogas Safety and Security magazine, to view content from past magazines, and to participate in October's Country Focus Month on the Nordic biogas market. I'd like to thank everyone for taking the time to join us today, and thank our presenters again, Dave Ellis with Azura Associates, Katrin Kayser with IBBK Biogas, and John Bickers with MRU Instruments. Thanks, everybody.
Thank you. Bye-bye.
Thank you.
Bye-bye.
Bye.